Section 12.3, Geometric Sequences, Geometric Series. Now, a geometric sequence may be defined recursively as A1 equals A and AN equals R times N minus 1, where A1 equals A and R are real numbers. The number A1 is called the first term, and the non-zero number R is called the common ratio. So R is called the common ratio here. Now we've dealt with at least a couple of these already. I'm going to write one out for you so we can take a look at this more in detail from the definition formally stated here. So when I look at this sequence here, 2, 4, 8, 16, 32, 64, one thing you may realize here that to get from 2 to 4, I had to, it looks like I could add 2 there, doesn't it? So I'm just going to put a plus 2 for just a second here. But now let's take a look at the next one. That's going to be 8. So it's not adding, is it? Because that would be like a 4 I'm adding there. So it wouldn't work quite that way. So the way this works is, what multiplier could I multiply times 2 to get 4? So I would say that now is going to be times 2. So then to go to the next one, that would also be a times 2. And from 8 to 16, that would also be a times 2. So what's going on here is I'm timesing 2 every time. So I'm just going to write the rest of them in there, because I want you to see something here. So then the recursive formula is very simple. Once I see that that multiplier here is 2, this becomes very easy, because this right here, the A1 equals A and the AN equals R times A to the N minus 1 really says it all for me. So that's really my formula. So A1, I would say, is 2, and AN equals, and my R is 2, so 2 times AN minus 1. That's it. That would be the recursive formula for that sequence. And that's a geometric sequence, because we have this multiplier instead of the addition. When it's an addition of, it's arithmetic. When it's a multiplier of, it's called geometric. So that's how we tell the difference between the two. So now let's take a look at the explicit form for this, because the recursive isn't one we generally use, but the explicit formula we will. And that's this formula right here. It says a geometric sequence A sub n, whose common ratio is R. The nth term is determined by the formula right down here. So this is actually my formula for the explicit formula for this. So I know R already, which is here, and I know A1 already, so that's really it. So I'm just going to write A sub n, and A1, that's my first term, is 2. So I'm going to write 2 times, and my R here is 2. And then that would be to the N minus 1. So this would be the formula for the explicit formula. So again, so the recursive formula and the explicit formula. So there you go. 2 different ways to think of these geometric sequences.